Greetings to every one of you. This is Professor Shanavas. Today we are going to discuss an important concept from data structures, single source shortest path algorithm, also called Dijkstra's algorithm, in which we have to find out the optimal solution for the given problem, minimal solution for the given problem. So naturally we will find out the minimum cost to get the solution. Here the problem is given here, which is represented in the form of a graph, and we have to find out what is the minimum cost to reach a source node to a destination node. Consider here S is the source is A and all other nodes are destination. The cost of reaching the node B from A is 2. Similarly, cost of reaching H from A is 4. Similarly, reaching E is 5, etc. And this particular problem can be solved using the algorithm that is Dijkstra's, which says a technique called selecting the minimum cost to reach a destination from a source. Let us consider we have 3 nodes, 1, 2, 3, and cost of reaching 2 from the source, that is 1, it is 2, and similarly cost of reaching node 3 from 2, it is 4. So from the source, that is 1 to 2, if you reach, the cost is that is 2. Let us consider this is U and V, but we don't know what is the cost of reaching 3 from 1, right? So 1 to 2 we know, but 1 to 3 we don't know, so that is considered as infinity. If you say this is U and this is V, the distance of U plus the cost of reaching U to V, if it is less than the distance of V, then we can calculate the distance of V as distance of U plus cost of reaching U to V. So in this case, the distance of V can be calculated as the distance of U, it is 2, and the cost of reaching from U to V, it is nothing but 4. So this is 2 and this is 4. So the total value is 6. So 6 is minimum than the infinity. So we have to take 6 as the value. So reaching, that is 1 to the node 3, that is 6. So this concept we are going to use in this graph. So consider the step number 1. So A is the source node. What are the destination? So the remaining nodes are, that is B, H, E, C, Z, all these are the destination nodes. And now we have to calculate what is the distance from A to, that is B, A to E, A to H, A to C and A to Z. So see here, A to B it is nothing but 2, reaching, that is A to E, it is 5, D, that is distance from A to H, it is 4, distance from A to C, actually that is we don't know, that is infinitive. Similarly, reaching, that is A to Z, that is also infinitive, because they don't have what is a direct connection. Okay, so with the help of, that is from the source, we can reach all these nodes using this cost. Now we have to consider the minimum cost. As I said, we have to consider the minimum. You compare all these values, which is the minimum, this is the minimum, 2 is the minimum. So its corresponding node it is B, that should be included in the source list. Now our source list is updated. This is what is called relaxation. The technique is what is called relaxation. So this node is what is that included here. So AB, now AB are what's that the source nodes, and remaining nodes are the destination E, H, C, Z. So now find out the distance from A to E. A to E is 5. A to E is 5. A to H is 4. Similarly, A to C, now A to C is 7. How? See that for reaching C, you can use that is B, because B is available in the source list. So make use of B, that is reaching B, it is 2. From B to C, you can use the cost, that is 5. So the total value is 7. So A to C, it is 7. Then again A to Z, we don't know, that is infinity. Okay. Now what is the minimum value? You compare all these value, take the minimum. So minimum is 4. Its corresponding node is H, and that should be included in the source list. Okay. Now find out the distance from, that is A to E. A to E, it is 5. Okay. Then A to C is 6. How? For for reaching C, we have now two paths, because this H is also available in the source list. So what we can do, we can reach C through B as well as through H. So if you use B, the cost is 7. If you use that is H, it is 4 plus 2, that is 6. You have to take the minimum value. So in that way, reaching that is C through H is minimum. So that is 6. Then again A2, that is Z, it is nothing but what's that? A2 Z is nothing but infinity. So compare all these values, take the minimum one. Which is the minimum one? 5 is the minimum. Okay, so it's corresponding the node, it is nothing but E. So include that node in the source list. Okay, E is the minimum, what is that? So that node is included here. Now we have the remaining nodes, destination C and Z. Okay, now find out the distance from A to C and A to Z. What is A to C? It is 6. So already we calculated. What is this A to Z? A to Z, you can calculate. See, for reaching Z, you have one, what's that? E is available here. So with the help of E, you can reach, that is 5 plus 4, 5 plus 4, that is 9. This is one distance. And similarly, you can take this H, you can make use of H. So 4, then 2, 4 plus 2 plus, then this is 5. So it is total, that is 11. Okay. So what are the other paths to reach Z? Also you can make use of what's that? You can reach A, B, then C. From what's that? C you can reach, that is Z. So it is 2 plus 5 plus 5, that is 12. 2 plus 5 plus 5, 12. So you have, that is 9, 11, 12. If you compare all these three, 9 is the minimum value. So you can select that particular, what's that? The value. A2 reaching, that is A2 is at the minimum, what's that? The minimum cost is through E. So E is that is the minimum cost. Okay. So compare all these three, which is the minimum value. Minimum value is 3. So that being the case, what's that? C is what's that? C is included in the list. C is included in the list. Right? And finally, we have, there is only one node, that is Z. So A to Z, that is 9. Now take all these values, that is in the list, that is A, B, H, E, C, D. You got the list. So if you consider the path is concerned, so A to B, that is minimum value is 2. A to H, that is a minimum value, that is 5. A to E, that is a minimum value, that is 5. And A to H, the minimum value is what is that? A to C, that is minimum value through H, that is 6. Similarly, A to Z through E, the minimum value is 9. Okay. So in this algorithm, we solve a given problem and find out the results, that is shortest path from the single source. A is the source. From A we are finding out what is that? The distance to all other nodes. I hope you understand the concept. Thank you.